In this question, we have to find the derivative of the function x square minus 2 at x is equal to 10. Let's begin with the solution. And let us define the given function by fx. So fx is equal to x square minus 2. Now we have to find the derivative. Derivative is given by f dash x, that is d upon dx of the function x square minus 2. So this is equal to d dx of x square minus d dx of 2. Now this is equal to 2 into x raised to the power 2 minus 1, since we know that derivative of x raised to the power n is equal to n into x raised to the power n minus 1. Here n is 2, so we have 2x raised to the power 2 minus 1, and derivative of the constant function is 0. So this is equal to 0. So we have 2x. Therefore, f dash x is equal to 2x. Now we have to find the value of the derivative at x is equal to 10. That is, we have to find f dash 10. So this is equal to 2 into 10, which is equal to 20. Therefore, derivative of x square minus 2 at x is equal to 10 is 20. In this question, we have to find the derivative of 99x at x is equal to 100. Let's begin with the solution, and let us define the given function as fx. So fx is equal to 99x. We have to find f dash x, that is derivative of the given function with respect to x. Now taking 99 out of the derivative, we have to find the derivative of x, which can be written as x raised to the power 1. Now we know that derivative of x raised to the power n is equal to n into x raised to the power n minus 1. Therefore, this can be written as 99 into 1 into x raised to the power 1 minus 1. That is 99 into 1 into x raised to the power 0. Now since x raised to the power 0 is 1, therefore this is equal to 99. Now we have to find the derivative at x is equal to 100. That is, we have to find derivative of the given function fx at x is equal to 100, which is f dash 100. Now the derivative is 99. Since 99 is independent of x, therefore the derivative of 99x at x is equal to 100 is 99. This completes the solution. In this question, we have to find the derivative of x at x is equal to 1. Let's begin with the solution. This is quite a simple problem. First, let us define the given function as fx. So fx is equal to x. We have to find f dash x, function x with respect to x, and this is equal to 1. Therefore, f dash 1, since we have to find the derivative at x is equal to 1, is equal to 1. Here, since 1 is independent of x, therefore f dash 1 is also equal to 1. So this was quite a simple problem. Therefore, we can say that the derivative of x at x is equal to 1 is 1. This completes the solution. In this question, we have to find the derivative of the following functions from the first principle. Let's begin with the solution. Now first let us find the derivative of x cube minus 27. Let the given function be defined as fx. So fx is equal to x cube minus 27. We have to find f dash x. Now from the first principle we know that it is given by limit as h tends to 0 f of x plus h minus fx divided by h. So this is equal to limit as h tends to 0. Now f of x plus h is x plus h whole cube minus 27. Then we have minus of fx, which is x cube minus 27, and the denominator we have h. This is equal to limit as h tends to 0. Now we know that x plus h whole cube is given by x cube plus h cube plus 3 x square h plus 3x h square minus 27. Now opening the second bracket we have minus x cube plus 27 whole divided by h. Now cancelling the terms x cube and minus x cube, minus 27 and plus 27, we have limit as h tends to 0. Now taking h common, from the remaining terms we have h square plus 3x square plus 3xh divided by h, and this is equal to, now since h tends to 0, replacing h by 0, here we have 0 square plus 3x square plus 3x into 0, which is equal to 0, plus 3x square plus 0, which is equal to 3x square. Therefore, the derivative of the function fx is 3x square. Or we can also write that the derivative of the given function x cube minus 27 is equal to 3x square. Now let us find the derivative of the second part. Again let us define the given function by fx. So we have fx is equal to x minus 1 into x minus 2, and this can be written as x square minus x minus 2x plus 2, that is x square minus 3x plus 2. Now let us find the derivative. Now from the first principle, the derivative is given by limit as h tends to 0 f of x plus h minus fx divided by h. So this can be written as limit as h tends to 0. Now we have x plus h whole square minus 3 into x plus h plus 2. For the function f of x plus h, we have replaced x by x plus h in the function fx. Then we have minus fx, that is x square plus 3x plus 2 whole divided by h. Sorry, this is minus here. Now opening the brackets, this can further be written as limit h tends to 0 x square plus 2xh plus h square minus 3x minus 3h plus 2 minus x square plus 3x minus 2 whole divided by h. Now cancelling the terms, x square cancels out with minus x square, minus 3x by plus 3x, and plus 2 by minus 2. We have limit as h tends to 0. In the numerator we have 2xh plus h square minus 3h divided by h. Now let us take h common from the numerator. We have limit as h tends to 0, h into 2x plus h minus 3 whole divided by h, cancelling h from the numerator and denominator. And now as h tends to 0, therefore replacing h by 0, we have 2x plus 0 minus 3. So this is equal to 2x minus 3. Therefore, the derivative of the given function is 2x minus 3, or this can also be written as d dx of the function x minus 1 into x minus 2 is equal to 2x minus 3. This completes the solution. In this question, we have to find the derivative of the following functions from the first principle. Let's begin with the solution. And let us define the given function as fx. So fx is equal to 1 upon x square. Now let us find the first derivative. Now we know that from the first principle f dash x is given by limit as h tends to 0 f of x plus h minus fx divided by h. This can be written as limit as h tends to 0. Now we have 1 upon x plus h whole square minus 1 upon x square whole divided by h. Now this is equal to limit as h tends to 0. In the numerator, taking the LCM, we have x plus h whole square into x square. Then we have x square minus x plus h whole square whole divided by h. And this is equal to limit as h approaches to 0, x square minus opening x plus h whole square, we have x square minus 2xh minus h square whole divided by x square into x plus h whole square into h. Now cancelling x square with minus x square and taking h common from the numerator, we have limit as h approaches to 0, h into minus 2x minus h whole divided by h into x plus h whole square into x square. Now cancelling h from the numerator and denominator, we further have limit as h approaches to 0, minus 2x minus h divided by x plus h whole square into x square. Now as h approaches to 0, therefore replacing h by 0, we have minus 2x minus 0 divided by x plus 0 whole square into x square. So this is equal to minus 2x divided by x raised to the power 4, which is equal to minus 2 divided by x cube. Therefore, f dash x is equal to minus 2 divided by x cube, or we have derivative of the given function is equal to minus 2 upon x cube. This completes the solution. Now let us proceed on to the fourth part. In fourth part we have to find derivative of x plus 1 divided by x minus 1. So first let us define the given function by fx. Now we know that from the first principle f dash x is given by limit as h tends to 0 f of x plus h minus fx divided by h. So this is further equal to limit as h approaches to 0 x plus h plus 1 divided by x plus h minus 1 minus of x plus 1 divided by x minus 1 whole divided by h. This is further equal to limit as h approaches to 0. Now taking the LCM of x plus h minus 1 and x minus 1, in the numerator we have x plus h plus 1 into x minus 1 minus of x plus 1 into x plus h minus 1 whole divided by h. This is further equal to limit as h approaches to 0. In the denominator we get h into x plus h minus 1 into x minus 1, and in the numerator we have multiplying x plus h first with x minus 1 we get x plus h into x, then we have minus of x plus h, then multiplying 1 with x minus 1 we get plus x minus 1. Now multiplying x with x plus h gives x into x plus h, and multiplying x with minus 1 gives minus x, and minus into minus is plus, so we have plus x. Now multiplying 1 with x plus h we get minus of x plus h, and then 1 into minus 1 is minus 1, and minus into minus is plus. Now cancelling the terms, x into x plus h cancels out with minus x into x plus h, and minus 1 with plus 1. So this is further equal to limit as h tends to 0. In the numerator we have minus of x plus h 2 times, therefore minus 2 times of x plus h. Then we have x 2 times, therefore plus 2x whole divided by h into x plus h minus 1 into x minus 1. This is further equal to limit as h tends to 0. In the numerator, on opening the brackets, we have minus 2x minus 2h plus 2x whole divided by h into x plus h minus 1 into x minus 1. Now minus 2x plus 2x cancels out. Now cancelling h from the numerator and denominator, we have limit as h tends to 0 minus 2 divided by x plus h minus 1 into x minus 1. Now as h tends to 0, therefore replacing h by 0, in the function we have minus 2 divided by x plus 0 minus 1 into x minus 1, and this is equal to minus 2 divided by x minus 1 into x minus 1, that is x minus 1 whole square. Therefore f dash x is equal to minus 2 divided by x minus 1 whole square, or we can say that ddx of the function x plus 1 divided by x minus 1 is equal to minus 2 divided by x minus 1 whole square. This completes the solution. In this question we are given a function fx and we have to prove that the derivative of fx at x is equal to 1 is equal to 100 times the derivative of fx at x is equal to 0. Let's begin with the solution, and the given function is fx is equal to x raised to the power 100 divided by 100 plus x raised to the power 99 divided by 99 plus so on up to x square divided by 2 plus x plus 1. Now its first derivative is given by f dash x, that is derivative of each term one by one with respect to x. So we have d dx of x raised to the power 100 divided by 100 plus derivative of the second term with respect to x plus so on up to the derivative of x square divided by 2 with respect to x plus derivative of x with respect to x plus derivative of 1 with respect to x. Now we know that derivative of a function x raised to the power n with respect to x is given by n into x raised to the power n minus 1. Therefore, using this, the derivative of the given function fx with respect to x is given by, now differentiating the first term with respect to x, we get 100 into x raised to the power 100 minus 1 divided by 100 plus, now differentiating the second term with respect to x, we get 99 into x raised to the power 99 minus 1 divided by 99 plus, now differentiating x square upon 2 with respect to x, we get 2x raised to the power 2 minus 1 divided by 2 plus, on differentiating x with respect to x, we get 1 plus, on differentiating 1 with respect to x, we get 0. Thus this is further equal to cancelling 100 with 100. We have x raised to the power 99 plus, cancelling 99 with 99 from the numerator and denominator, which is the common factor, we have x raised to the power 98 plus so on. Now here cancelling the common factor 2 from the numerator and denominator, we have x raised to the power 2 minus 1, which is 1 plus 1. Therefore, f dash x is equal to x raised to the power 99 plus x raised to the power 98 plus so on up to x plus 1. Now let us find the derivative of the function at x is equal to 1. So we get 1 raised to the power 99 plus 1 raised to the power 98 plus 1 raised to the power 97 plus so on plus 1 plus 1. Now up to x, these are 99 terms and this is one more term. Therefore, in all we have 1 plus 1 plus 1 plus 1 so on up to the last one 100 times. So this is equal to 100. Now let us find f dash 0. Now this is f dash x. So we have 0 raised to the power 99 plus 0 raised to the power 98 plus so on plus 0 plus 1. So f dash 0 is 1, that is the derivative of the function at x is equal to 0 is 1. Therefore, f dash 1 is equal to 100 can be written as 100 into 1, and 1 is nothing but the derivative of the function at x is equal to 0. So this can be written as 100 into f dash 0. Hence we have f dash 1 equal to 100 times of f dash 0. This completes the solution. In this question, we have to find the derivative of the given function for some fixed real number a. Let's begin with the solution. And first let us define the given function as fx. So fx is equal to x raised to the power n plus a into x raised to the power n minus 1 plus a square x raised to the power n minus 2 and so on up to a raised to the power n minus 1 into x plus a raised to the power n, where a is a real number. Now we know that derivative of a function x raised to the power n with respect to x is given by n into x raised to the power n minus 1. Therefore, we will be using this to find the derivative f dash x. Let us first find the derivative of the first term with respect to x plus the derivative of the second term with respect to x, then the derivative of the third term with respect to x, plus so on up to the derivative of the second last term with respect to x, plus the derivative of the last term with respect to x. Now this is equal to derivative of x raised to the power n with respect to x is n into x raised to the power n minus 1, then plus, now derivative of a into x raised to the power n minus 1 with respect to x is given by a, which is a constant, therefore taking it out. Now we have to find the derivative of x raised to the power n minus 1, which is n minus 1 into x raised to the power n minus 1 minus 1. Now the derivative of the third term is given by a square into n minus 2. A square is constant. Now we are finding the derivative of x raised to the power n minus 2, which is n minus 2 into x raised to the power n minus 2 minus 1 plus so on up to a raised to the power n minus 1, which is again a constant, and derivative of x with respect to x is 1 plus, now derivative of any constant with respect to x is 0. Therefore we have n into x raised to the power n minus 1 plus a into n minus 1 x raised to the power n minus 2 plus a square into n minus 2 x raised to the power n minus 3 plus so on up to a raised to the power n minus 1. So we have found the derivative of the given function fx. Now we have to find the derivative of the given function fx for some fixed real number a. That is, we have to find f dash a. Now replacing all the x in this equation by a, we have n into a raised to the power n minus 1 plus a into n minus 1 into a raised to the power n minus 2 plus a square into n minus 2 into a raised to the power n minus 3 plus so on up to a raised to the power n minus 1. Now this is further equal to n into a raised to the power n minus 1 plus n minus 1 into a raised to the power, this is 1. So on adding the exponents we have 1 plus n minus 2 plus n minus 2 into a raised to the power 2 plus n minus 3 plus so on up to a raised to the power n minus 1, and this is further equal to n into a raised to the power n minus 1 plus n minus 1 into a raised to the power n minus 1 plus n minus 2 into a raised to the power n minus 1 plus so on up to a raised to the power n minus 1. Now we see that a raised to the power n minus 1 is common in all the terms. Therefore, taking this as a common factor, we are left with n plus n minus 1 plus n minus 2 plus so on up to 1. Now, this is equal to a raised to the power n minus 1, and this is nothing but the sum of first n natural numbers right, and therefore we have a raised to the power n minus 1 into n plus 1 divided by 2, which is the sum of first n natural numbers. Therefore, the derivative of the given function for some fixed real number a is a raised to the power n minus 1 into n plus 1 divided by 2. This completes the solution. Here in this question, we have to find the derivative of the function x minus a into x minus b for some constants a and b. Let's begin with the solution, and let us define the given function by fx. So fx is equal to x minus a into x minus b. Now we know that the derivative of the product of two functions is given by the product rule, that is the derivative of the second function into the first function plus the second function into the derivative of the first function. So let us now find out the derivative of fx with respect to x. So we have d dx of fx, or also we can write f dash x. So this is equal to x minus a into derivative of x minus b with respect to x plus x minus b into derivative of the first function, that is x minus a. Now this is further equal to x minus a into derivative of x minus b with respect to x is 1 minus 0, since derivative of x with respect to x is 1 and derivative of constant with respect to x is 0, plus x minus b into, similarly here we have 1 minus 0. So we have x minus a plus x minus b, which is equal to 2x minus a minus b. Therefore, derivative of the given function x minus a into x minus b with respect to x is 2x minus a minus b. This completes the solution. In this question, we have to find the derivative of ax square plus b whole square for some constants a and b. Let's begin with the solution. Let us define the given function by fx. So fx is equal to ax square plus b whole square. Now we have to find its derivative, that is we have to find f dash x, or the derivative of the function with respect to x. Now we know that derivative of a function x raised to the power n with respect to x is given by n into x raised to the power n minus 1. So here, in place of x we have ax square plus b. So we have 2 times ax square plus b raised to the power 2 minus 1 into the derivative of the function, which is ax square plus b. Now this is further equal to 2 times of ax square plus b raised to the power 1 into derivative of ax square is 2 times of ax plus derivative of b with respect to x is 0 since b is a constant. Therefore we have 2 2s are 4 ax into ax square plus b. Therefore the derivative of the given function ax square plus b whole square with respect to x is 4ax into ax square plus b. This completes the solution. In this question we have to find the derivative of the quotient x minus a divided by x minus b, where a and b are constants. Let's begin with the solution. And let us define the given function by fx. So fx is equal to x minus a divided by x minus b. Now we know that the derivative of the quotient of hx divided by gx is equal to gx into the derivative of hx minus hx into the derivative of gx whole divided by gx whole square. So here gx is x minus b and hx is x minus a. So now let us find f dash x, that is derivative of x minus a divided by x minus b. So this is equal to, now this is equal to gx, which is x minus b, into the derivative of hx, which is x minus a, minus hx into the derivative of gx, which is x minus b, whole divided by gx whole square, that is x minus b whole square. Now this is further equal to x minus b and derivative of x minus a with respect to x is 1 minus 0, since derivative of x with respect to x is 1 and derivative of a constant with respect to x is 0. Then we have minus x minus a into similarly 1 minus 0 whole divided by x minus b whole square. Now this is equal to x minus b into 1 is x minus b minus of x minus a whole divided by x minus b whole square. This is further equal to x minus b minus x plus a whole divided by x minus b whole square. Now cancelling x and minus x, we have minus b plus a whole divided by x minus b whole square. Therefore, the derivative of the given function x minus a divided by x minus b with respect to x is a minus b whole divided by x minus b whole square. This completes the solution. In this question, we have to find the derivative of x raised to the power n minus a raised to the power n divided by x minus a for some constant a. Let's begin with the solution and let the given function be denoted by fx. So fx is equal to x raised to the power n minus a raised to the power n divided by x minus a. Now we know that derivative of the quotient of two functions is given by the shown quotient rule. Therefore, applying this quotient rule to fx, we have to find the derivative of fx with respect to x. So first we have x minus a. Since here gx is x minus a and hx is x raised to the power n minus a raised to the power n, now we have to find the derivative of the function x raised to the power n minus a raised to the power n minus hx. hx is x raised to the power n minus a raised to the power n into the derivative of gx, which is x minus a, whole divided by gx whole square, and here gx is x minus a, so we have x minus a whole square. Now this is further equal to x minus a into the derivative of x raised to the power n minus a raised to the power n, and derivative of the difference of two functions is the difference of the derivatives of the function, and here the derivative of a raised to the power n is 0 since it is a constant function. Therefore, here we have n into x raised to the power n minus 1. Then we have minus x raised to the power n minus a raised to the power n. Now we have to find the derivative of x minus a with respect to x. Similarly, x minus a is the difference of two functions, and we know that derivative of the difference of two functions is the difference of the derivatives of the function, and here the derivative of a, which is a constant function, is 0. Therefore, here we have 1 minus 0 whole divided by x minus a whole square. Now this is equal to x minus a into n raised to the power x minus 1 minus x raised to the power n minus a raised to the power n divided by x minus a whole square. This is further equal to n into, now multiplying x with x raised to the power n minus 1 gives x raised to the power n. Then we have minus an x raised to the power n minus 1. Now opening the second bracket, we have minus x raised to the power n plus a raised to the power n whole divided by x minus a whole square. Therefore, this is our required derivative, that is f dash x is equal to n into x raised to the power n minus an into x raised to the power n minus 1 minus x raised to the power n plus a raised to the power n whole divided by x minus a whole square. So this is what we are required to find in this question. In this question, we have to find the derivative of the following three functions. Let's begin with the solution, and let us define the first function by fx. So fx is equal to 2x minus 3 upon 4. We have to find its derivative, that is, we have to find f dash x, or the derivative of the given function with respect to x. Now this is equal to derivative of 2x with respect to x minus derivative of 3 upon 4 with respect to x, and this is because derivative of the difference of two functions is the difference of the derivatives of the function. Now this is equal to 2 times the derivative of x, taking the constant outside the derivative, minus derivative of the constant function with respect to x is 0. This is equal to 2 into derivative of x with respect to x is 1 minus 0, so 2 minus 0 is 2. Therefore, derivative of 2x minus 3 upon 4 with respect to x is 2. the derivative of the second function, defining the second function by hx. So hx is equal to 5x cube plus 3x minus 1 into x minus 1. We have to find its derivative, that is, we have to find the derivative of the function hx with respect to x. So we have derivative of 5x cube plus 3x minus 1 into x minus 1 with respect to x. Now applying the product rule, which is first function into the derivative of the second function plus the second function into the derivative of the first function Now this is further equal to 5x cube plus 3x minus 1. Now the derivative of x minus 1 with respect to x is 1 minus 0, since the derivative of the difference of two functions is the difference of the derivatives of the function, and here derivative of x with respect to x is 1 and derivative of 1 with respect to x is 0, since 1 is a constant, plus x minus 1 into, here we have 5 times the derivative of x cube plus 3 times the derivative of x plus derivative of minus 1. Now this is further equal to 5x cube plus 3x minus 1 plus x minus 1 into 5 times derivative of x cube with respect to x is 3 times of x raised to the power 3 minus 1. Since we know that derivative of x raised to the power n with respect to x is n times of x raised to the power n minus 1, and here n is 3, plus 3 times derivative of x with respect to x is 1, and derivative of minus 1 with respect to x is 0. This is further equal to 5x cube plus 3x minus 1 plus x minus 1 into 5 3s are 15, x raised to the power 2 plus 3. Now this is further equal to 5x cube plus 3x minus 1 plus, now multiplying x with the terms inside the bracket, we get 15 x cube plus 3x, now multiplying minus 1 with the terms inside the bracket, we get minus 15 x square minus 3. Now this is equal to 5x cube plus 15x cube gives 20x cube, 3x plus 3x gives plus 6x, then we use minus 1 and minus 3, which is minus 4. Therefore, the derivative of hx with respect to x is 20x cube minus 15x square plus 6x minus 4. This completes the second part. Now let us find the derivative of the third part. Let us define the given function by gx. So gx is equal to x raised to the power minus 3 into 5 plus 3x. This can further be written as 5 plus 3x divided by x cube. Now here we have the quotient of two functions. Therefore, to find the derivative of gx, we will apply the quotient rule. To find the derivative of 5 plus 3x divided by x cube with respect to x, and therefore we have x cube into the derivative of 5 plus 3x minus 5 plus 3x into the derivative of x cube whole divided by x cube whole square. Now this is further equal to x cube into derivative of this function with respect to x is 0 plus 3. Since we know that derivative of the sum of two functions is the sum of the derivatives of the function, and here the derivative of 5 is 0 since 5 is a constant, and derivative of 3x is 3 times derivative of x with respect to x, which is 1, and 3 ones are 3, minus 5 plus 3x, and here we have 3 times x raised to the power 3 minus 1, as we have done in the previous part, whole divided by x raised to the power 6. Now this is further equal to 3 times of x cube minus 5 plus 3x into 3x square whole divided by x raised to the power 6. This is further equal to 3x cube minus 3 5s are 15x square. Then we have 3 3s are 9, 9x cube. Then we have minus 9x cube whole divided by x raised to the power 6. Now this is further equal to minus 6x cube minus 15x square whole divided by x raised to the power 6. Now taking x square common from the numerator, we are left with minus 6x minus 15 divided by x raised to the power 6, which implies minus of 6x plus 15 divided by x raised to the power 4. Now we can also take 3 common from the bracket. So we have minus 3 divided by x raised to the power 4 into 5 plus 2x. Therefore, the derivative of the given function, which we have defined as gx, is equal to 3 upon x raised to the power 4 with a negative sign, 5 plus 2x. So this completes the solution. In this question, we have to find the derivatives of the following given 3 functions. Let's begin with the solution. In the first part, let us define the given function by fx. So fx is equal to x raised to the power 5 into 3 minus 6 times of x raised to the power minus 9. Now, we have to find f dash x. Now here we can see that we are given the product of two functions. Therefore, to find the derivative of fx, first we will find the product of the first function into the derivative of the second function, plus the second function into the derivative of the first function, which is called the product rule. Therefore, to find the derivative of fx, we have applied the product rule. Now this is equal to x raised to the power 5, and here we have the difference of two functions, and we know that the derivative of the difference of two functions is the difference of the derivatives of the function. Therefore, we have derivative of 3 minus 6 times derivative of x raised to the power minus 9 plus 3 minus 6x raised to the power minus 9 into derivative of x raised to the power 5 with respect to x is 5 times of x raised to the power 4, which we get on subtracting 1 from 5. Now this is further equal to x raised to the power 5. Now the derivative of constant with respect to x is 0 minus 6, and here the derivative of x raised to the power minus 9 is minus 9 into x raised to the power minus 9 minus 1. Since we know that derivative of x raised to the power n with respect to x is given by n into x raised to the power n minus 1. Therefore, here we have this plus 3 minus 6 into x raised to the power minus 9 into 5x raised to the power 4. Now this is further equal to x raised to the power 5 into 6 9s are 54 into x raised to the power minus 10 plus 5 3s are 15 x raised to the power 4. Now multiplying these two terms, we have minus 6 5s are 30 into x raised to the power minus 9 plus 4. So here we have 54 into x raised to the power 5 minus 10 plus 15 x raised to the power 4 minus 30 x raised to the power minus 5. This further implies that 54, and here we get x raised to the power minus 5, which can be written as divided by x raised to the power 5 plus 15 x raised to the power 4 minus 30 divided by x raised to the power 5. Now these two are like terms, therefore solving them together we get plus 24 divided by x raised to the power 5. Therefore, derivative of the first function, that is x raised to the power 5 into 3 minus 6 times of x raised to the power minus 9 is 15 x raised to the power 4 plus 24 divided by x raised to the power 5. Now let us find the derivative of the fourth part. Let us define the given function by hx. So hx is equal to x raised to the power minus 4 into 3 minus 4 into x raised to the power minus 5. Here again we have to find the derivative of the product of two functions, which is given by the product rule, that is the first function into the derivative of the second function plus the second function into the derivative of the first function. Now here we will again use the derivative of x raised to the power n with respect to x is n times x raised to the power n minus 1. Now this is equal to x raised to the power minus 4 into derivative of 3 with respect to x minus 4 times derivative of x raised to the power minus 5 with respect to x plus 3 minus 4x raised to the power minus 5, and the derivative of x raised to the power minus 4 with respect to x is given by minus 4 into x raised to the power minus 4 minus 1. Now this is further equal to x raised to the power minus 4. Derivative of a constant function with respect to x is 0 minus 4 times of derivative of x raised to the power minus 5 with respect to x is minus 5 x raised to the power minus 5 minus 1 plus 3 minus 4x raised to the power minus 5 into minus 4x raised to the power minus 5. This is further equal to x raised to the power minus 4 Then minus 4 into minus 5 is 20. X raised to the power minus 6 plus, then we have 3 minus 4x raised to the power minus 5 into minus 4x raised to the power minus 5. This is further equal to 20 x raised to the power minus 10. We will get minus 10 on adding minus 4 and minus 6 plus 3 into minus 4 x raised to the power minus 5 plus minus 4x raised to the power minus 5 into minus 4x raised to the power minus 5, and this is equal to 20x raised to the power minus 10 minus 12x raised to the power minus 5. Then minus minus is plus, so we have plus 16x raised to the power minus 10. Now 20x raised to the power minus 10 and 16x raised to the power minus 10 gives 36x raised to the power minus 10 minus 12x raised to the power minus 5. Or this can be written as minus 12 divided by x raised to the power 5 plus 36 divided by x raised to 4. Derivative of the function x raised to the power minus 4 into 3 minus 4x raised to the power minus 5 is equal to minus 12 divided by x raised to the power 5 plus 36 divided by x raised to the power 10. Let us now move on to the last part and define the given function by gx. So gx is equal to 2 divided by x plus 1 minus x square divided by 3x minus 1. Now let us find the derivative. Here we have the difference of two functions, and both the functions are the quotient of two functions. Therefore, here we will apply quotient rule on both the terms one by one. So here we have to find the derivative of 2 divided by x plus 1 minus x square divided by 3x minus 1. And we know that derivative of the difference of two function is the difference of the derivatives of the two function, that is derivative of 2 upon x plus 1 minus derivative of x square divided by 3x minus 1. Now this is equal to, now applying the quotient rule, we have x plus 1 into derivative of the constant function minus the constant function into the derivative of x plus 1 whole divided by x plus 1 whole square. Now applying the quotient rule to x square divided by 3x minus 1, we have 3x minus 1 into the derivative of x square minus x square into the derivative of 3x minus 1 whole divided by 3x minus 1 whole square. Now this is further equal to x plus 1, and derivative of constant function with respect to x is 0 minus 2 times of derivative of x plus 1 is 1 plus 0. Since derivative of x with respect to x is 1 and derivative of 1 with respect to x is 0, whole divided by x plus 1 whole square minus 3x minus 1. Now derivative of x square is 2x minus x square, and derivative of 3x minus 1 is 3 minus 0. Since derivative of 3x with respect to x is 3 into 1, that is 3, and derivative of constant with respect to x is 0, whole divided by (3x minus 1) whole square. Now let us simplify it further. On multiplying 0 with x plus 1 gives 0. Then we have minus 2 into 1, which is minus 2, divided by x plus 1 whole square. Then minus, on multiplying 3x with 2x we get 6x square, minus 2x into 1 gives 2x, minus 3x square, divided by 3x minus 1 whole square. This is equal to minus 2 divided by x plus 1 whole square, minus, now 6x square minus 3x square is 3x square, minus 2x divided by 3x minus 1 whole square, which is further equal to minus 2 divided by x plus 1 whole square. Now taking x common from these two terms, we get minus x into 3x minus 2 divided by 3x minus 1 whole square. Therefore, the derivative of the given function 2 upon x plus 1 minus x square divided by 3x minus 1 is equal to minus 2 divided by x plus 1 whole square minus x into 3x minus 2 divided by 3x minus 1 whole square. So this completes the solution. In this question, we have to find the derivative of cos x from the first principle. Let's begin with the solution. And let us denote the given function by fx. So fx is equal to cos x. We have to find its derivative, that is, we have to find f dash x from the first principle, and from the first principle f dash x is given by limit as h tends to 0 f of x plus h minus fx whole divided by h. Now this is further equal to limit as h tends to 0 cos of x plus h minus cos x divided by h. Since f of x plus h is cos x plus h, we have replaced x by x plus h. Now we know that cos a minus cos b is equal to minus 2 sin a plus b divided by 2 into sin a minus b divided by 2, and here a is x plus h and b is x. Therefore, this can further be written as limit as h tends to 0 minus 2 sin a plus b is x plus h plus x, that gives 2x plus h divided by 2 into sin a minus b, so we have x plus h minus x, that is h divided by 2 and whole divided by h. Now taking the minus sign out of the limit, we have limit h tends to 0 sin x plus h upon 2 into sin h upon 2 divided by this h, and taking this 2 in the denominator. This is further equal to minus limit h tends to 0 sin of x plus h upon 2 into limit. Since h tends to 0, therefore h upon 2 tends to 0. We have sin h upon 2 divided by h upon 2, and this is because limit of the product of two function is the product of the limits of the function. This is further equal to minus. Now since h tends to 0, therefore here replacing h by 0, we have sin x, and the limit h upon 2 tends to 0, sin h upon 2 divided by h upon 2 is 1, and on multiplying sin x with 1 we get minus sin x. Therefore, derivative of cos x with respect to x is minus sin x. This completes the solution. In this question, we have to find the derivative of the following functions. Let's begin with the solution. And first let us find the derivative of sin x into cos x. Defining this function by fx. Now we have to find its derivative, that is f dash x. We have to find its derivative with respect to x. Now we see that here we are given the product of two functions. Therefore, the derivative of the product of two functions is given by the first function into the derivative of the second function plus the second function into the derivative of the first function, and this is equal to sin x, and derivative of cos x is minus sin x plus cos x, and derivative of sin x with respect to x is cos x. Therefore, we have minus sin square x plus cos square x, which is equal to, in other words, cos square x minus sin square x, and this is nothing but cos 2x. Therefore, the derivative of sin x into cos x with respect to x is given by cos 2x. Now let us proceed on to the second part. Let us define the given function by gx. So gx is equal to sec x. Now we have to find the derivative of sec x, that is the derivative of sec x with respect to x. This can be written as 1 upon cos x. Now applying the quotient rule here, to find its derivative we have cos x into derivative of 1 minus 1 into the derivative of cos x divided by cos x whole square, and this is equal to cos x, and derivative of a constant function with respect to x is 0, minus 1 into derivative of cos x with respect to x is minus sin x divided by cos square x. Now this is equal to sin x divided by cos square x. Now this can be written as sin x divided by cos square x, that is sin x divided by cos x into 1 upon cos x, and sin x divided by cos x is tan x, and 1 upon cos x is sec x. Therefore, derivative of the given function sec x with respect to x is tan x sec x. Now let us proceed on to the third part. Let us define the given function by hx. So hx is equal to 5 sec x plus 4 time of cos x. We have to find h dash x, that is derivative of the given function with respect to x. Now as we can see here, we are given the sum of the two functions and we have to find its derivative, And we know that the derivative of the sum of two functions is the sum of the derivatives of the function, that is 5 times of derivative of sec x with respect to x plus 4 times derivative of cos x with respect to x. Now in the second part we have found out that derivative of sec x with respect to x is sec x into tan x plus 4 times of derivative of cos x is minus sin x. So this is equal to 5 sec x into tan x minus 4 sin x. Therefore, the derivative of the function 5 sec x plus 4 cos x is equal to 5 sec x into tan x minus 4 sin x. This completes the solution. In this question, we have to find the derivative of the following functions. Let's begin with the solution. And let us begin with the fourth part, defining the given function by fx. So fx is equal to cosec x. We have to find its derivative, that is ddx of cosec x, and cosec x is nothing but 1 upon sin x. Now let us find the derivative of 1 upon sin x with respect to x with the help of quotient rule. So this is equal to sin x into the derivative of 1 minus 1 into the derivative of the sin x divided by sin x whole square. Now this is further equal to sin x into, now derivative of 1 with respect to x is 0, minus 1, and derivative of sin x is cos x, and sin x whole square is sin square x. Now this is equal to minus cos x divided by sin square x, or it can be written as minus of cos x divided by sin x into 1 upon sin x, and cos x upon sin x is cot x, and 1 upon sin x is cosec x. Therefore, we can say that the derivative of the function cosec x is equal to minus cot x into cosec x. Let us now find the derivative of the fifth part, defining the given function by hx. So hx is equal to 3 cot x plus 5 cosec x. We have to find h dash x, that is derivative of the given function with respect to x. Now we know that the derivative of the sum of the two functions is the sum of the derivatives of the function. So we have 3 times derivative of cot x with respect to x plus 5 times derivative of cosec x with respect to x. Now let us find the derivative of cot x. So we have 3 times ddx of cot x can be written as cos x divided by sin x. And now to find this derivative, we will apply the quotient rule in the next step. And further we have 5 times. Now derivative of cosec x, as we have found in the fourth part, is minus cot x into cosec x. So here we have minus cot x into cosec x. Now let us apply the quotient rule here. So we have 3 times sin x into derivative of cos x minus cos x into derivative of sin x divided by sin x whole square plus 5 times of minus cot x into cosec x. Now this is further equal to 3 times of sin x. Now derivative of cos x is minus sin x minus cos x, and derivative of sin x is again cos x divided by sin square x, then plus into minus is minus, then we have 5 cot x into cosec x. Now this is further equal to 3 times of minus sin square x minus cos square x divided by sin square x minus 5 times of cot x into cosec x. Now taking the minus sign common, we have minus 3 times of sin square x plus cos square x, which is 1, divided by sin square x minus 5 cot x into cosec x. Now this is equal to minus 3 cosec square x minus 5 cot x into cosec x. Now taking minus cosec x common from both the terms, we have 3 cosec x plus 5 cot x. Therefore, the derivative of 3 cot x plus 5 cosec x is equal to minus cosec x into 3 cosec x plus 5 cot x. Now let us move on to the sixth part. In the sixth part, again we have to find the derivative. So let us define the function by gx. So gx is 5 sin x minus 6 cos x plus 7, and we have to find g dash x, that is derivative of the given function with respect to x. So we have ddx of 5 sin x minus 6 cos x plus 7, and this is equal to the derivative of 5 sin x minus derivative of 6 cos x plus derivative of 7. Now this is equal to 5 times derivative of sin x minus 6 times derivative of cos x plus derivative of a constant function with respect to x is 0. This is further equal to 5 cos x, since derivative of sin x is cos x, minus 6 times of, now derivative of cos x is minus sin x plus 0. So this is equal to 5 cos x plus 6 sin x. Therefore, derivative of 5 sin x minus 6 cos x plus 7 is equal to 5 cos x plus 6 sin x. Now proceeding on to the last part. In this part, let us define the function by px. So px is 2 tan x minus 7 sec x we have to find p dash x, that is the derivative of the given function with respect to x. Right? So this can be written as 2 times the derivative of tan x minus 7 times the derivative of sec x. Now tan x can be written as sin x divided by cos x minus 7 times of derivative of sec x, as we have found in the second part, is sec x into tan x. Now let us find the derivative of sin x divided by cos x with the help of product rule. So we have 2 times cos x into derivative of sin x minus sin x into derivative of cos x divided by cos x whole square. Then we have minus 7 sec x into tan x. This is further equal to 2 times of cos x, derivative of sin x is again cos x, minus sin x, and derivative of cos x is minus sin x, divided by cos square x minus 7 times of sec x into tan x. Now this is equal to 2 times of cos square x plus sin square x, which is equal to 1. So we have 1 divided by cos square x minus 7 times of sec x into tan x. This is further equal to 2 times of 1 upon cos x is sec x. Therefore we have sec square x minus 7 times of sec x into tan x. Therefore, derivative of the function 2 tan x minus 7 sec x with respect to x is 2 sec square x minus 7 sec x into tan x. This completes the solution.